Hello everyone. So today I am being a part of Women in Data Science Mysuru chapter of India. And I would like to thank Susha for reaching out and scheduling this talk. Um, Today we are going to speak about data science projects, uh, mm, uh, not theoretically, but how it goes in practice, like in industry, how we are thinking and going about data science projects. A bit about myself. I am Mohita Ajmera. I am working as a principal data scientist at Great Learning, and my role revolves around mm, solving different business issues using data science techniques, and also helping build better products by use of data driven processes. So in today's talk, I would like to highlight the outline. We will talk about, for a project, how you go about thinking on teams, different roles, and the skills which are required. How you actually align your project with the business requirements, and what is the process from starting from the problem identification to the implementation and deployment, and what after deployment. So let's get started. When we talk about teams, roles, and skills, it's actually a very wide topic, and it's discussed in different perspective about by different peoples, which are from different organizations and at different stages of their career. Whatever I am sharing, it is based on my experience. It might not be similar as the experience of other people in other companies, and it also depends upon which size company you are. The whole scenario is very different in a startup than at a mid-sized company, and that then at a bigger tech company. And also the data science work can revolve around either using machine learning AI or doing data visualization and reporting, and also just doing the hypothesis testing, experimenting, and just retuning different parameters of your model and uh, product. You can think about this as a product manager. You can think about it as a lead of data science. You can think about it as a pure technical or engineer person. So the what I'm meaning to say is that the scale is very vast, uh, and things change from company to company, person to person. The problem which you're trying to solve, and the uh, skills you have. Okay, so as you can see, you can have only a team of one person who is driving everything. You can have a team of 10 people, um, and if you have a team of one people, you will be the person who will be driving everything from problem definition to data exploration, data collection, to model deployment. So you could be called as a full stack data scientist, and you will have all the skills which required from data collection to deployment. And then if you have a team of 5 or 10 people or more, you can have a collection of different groups of people. Some people can be data engineer, some people can be data analyst, some people can be machine learning engineer, some people can be data scientists, some people can be business analyst, which sort of collaborate with different teams and at different points to get your project up and running. In terms of skill, um, it's always shared that you need to know Python, you need to know SQL, you need to know statistics and some machine learning techniques. But in my view, yes, those skills are important, then but more important skill is to have a curious mind, and also power of thinking holistically about how you can solve a problem, first at scale and for longer term, and whether it sort of gives some benefit to your organization in some way. Okay, So so this is about teams, roles and skills. Now going forward, let's think about what data science can be used for. So for a business, you can how you can benefit a business by either increasing the revenue or cutting the cost. Now these two dimension can be subdivided into different parts. The data science can help in optimizing some processes which are unnecessary, taking more time or taking more people, or using an unnecessary technology. um, that will lead to cost cutting. It can increase sales of profit if you sort of either improve your product or its features, or you are able to predict that what are the people who can enroll or convert for your product. uh, any of these can lead to a significant percentage of increase in sales and thus revenue. It can also help in improving user experience by understanding that where your users are dropping, uh, and what features they are using most, or which element of a feature is leading to the most good experience to your users. And there can be many other ways itself. In some organization, their product itself is based out of data science. um, in that case, data science is like, there's no other way than using data science to improve that. So to now we have learned that what different areas data science can be used for. Now think about how you go for problem identification. Okay, so you are trying to solve some problem using data science for an organization. It can be for different teams or different aspects. Like you can solve problem of marketing, of sales, you can solve problem of product, you can solve problem of a software, you can solve problem about the user and its experience. In any of these areas, you first need to decide the scope of the problem. What is the level of impact it will be giving to your business. You It's very important that you identify these two, and also write some sort of quantitative values to these in order to get the clarity about what you want to do. Then you need to think about the timeline. There can be a problem which needs to be solved in 10 days, but the whole data science process requires 1 month at least. In that case, you cannot sort of focus and solve that problem. You need to figure out some other ways to solve it. What will be the important milestones of your project? Like what you will be providing at, let's say, at an interval of 10 days, 15 days, and then 30 days. It gives a visibility to your stakeholders about what is going to come and at what time. And data science implementation is just not one time implementation. You need to think about iteration, because in first version it will be just like an MVP. You'll be just solving some problem, but you need to improve it. You need to make it better. So there will be many such iterations involved. The one thing which people sort of neglect sometimes is about calculating the risks. So you are creating a hypothesis that whatever process you are thinking to solve the problem, it will work. Now you also need to figure out and recognize that where it can fail. Whether it can fail by the data issue, whether it can fail by the technique issue, whether it can fail by the process issue, or some skill issue. Then you need to think about priority. What is the priority of this problem to be solved? Is it a high priority problem or low priority? Sometimes you just think of a problem and you get a problem and you start working on it, you create a whole plan, you get to implementation, and then you get to know, no, it was a low priority project. And then you either don't deploy it, or you just leave it as it is and then move on to the next problem. So it's very important to understand the priority of the project by different stakeholder, and like create a what if scenario, that what if this doesn't get implemented, what will be the loss and in what time. That will sort of give you the idea about the priority of the project. So once you have identified a problem, you need to think about data. So in data science, the data is one of the main factor. For a data science project, you need to have data. You need to have a good data. If you do not have good uh, quality data, it will be like a garbage in, garbage out. So first, you need to sort the problem of data availability and quality of the data in your organization. If you are able to collect, process, analyze the data, and also improve it over the time, uh, and keep on versioning it, adding proper documentation, then uh, from data collection to production and to to reuse the data or future use, you will have lesser issues as compared to if your data policies are not sorted, your data is not properly labeled, or it's not documented and not structured. So first, solve the problem of data in your company. Have a process created from generating, gathering, collecting the data to versioning and documenting. So the first step about after fixing about our data science project, after fixing the problem definition and specifying what we need exactly, we need to think about what data we need. So for example, let's say we have a project of how to predict which leads will convert for your product. Now if you think about this, we need data about the leads. Whatever we can collect about the leads will help us in our prediction. We need to have data about our product. How is the interaction happening between the product and the leads? We need to have the data about the sales people who are involved in selling these products. And we can have data about the journey of the user interaction with the website, if it is a online product, or some sort of collected data by surveys, which helps us understand the intent of the users, or the leads actually. So in many organization, most of the data is stored and kept in a database. It can be a NoSQL database or SQL database. So now you need to start thinking about those skills and which people will sort of have those skills who can fetch the data for you. The people who have knowledge about SQL, NoSQL databases, and if your data is on cloud, then a bit of cloud computing, data warehousing, those skills, along with a bit of programming skills like Python, will be required to collect and explore the data. So uh, basically you need to assign all of this part to the team members who have these skills and can have demonstrated good capabilities here. Um, the diagram here sort of shows that when you are going and collecting and exploring data, you think it to be a very linear situation, but exploration of data takes time. You can you will need to go through many strange outputs, visualization, issues, in order to finally get to a stage of the proper exploration. Once you have collected and started to explore data, your next step is to find the insights and create hypothesis. Now data is nothing without insights, and the insights are nothing without creating actionable hypothesis on those. Here the skills and roles of statisticians, who knows good about inferential statistics and data visualization help. You can use dashboarding tools like Power BI, Tableau, and all in order to properly visualize and get very in time insights of it, and also experiment and create hypothesis. Uh, so let's say for lead conversion prediction model, we need to understand which leads are converting more. What are those prominent features which are helping converting leads more? Whether whether females are converting more, whether age group of uh, 30 to 40 are converting more. What is the time period when your leads are coming to your website more? What is the talk time of those leads with different sales folks? So there can be many such important data points which can help you understand that for for any particular area, how that data uh, distribution is helping, and how you can create or propose a hypothesis and test it. So once you have sort of got a few insights and tested of some hypothesis, you can either go down the route of um, just having visualization to solve your problem, or you can think about some advanced things like machine learning. Now, whenever people are thinking about data science projects, they think mainly what they will be doing is creating ML model, but that's not the case in reality. Not all problems required machine learning. And that is important. And second, the time given to building machine learning model, or the time you will be able to get to build a machine learning model, will be very less as compared to time you will be spending on cleaning data, exploring data, and also explaining it to different stakeholders. Okay. um, Creating ML models is just like a tip of iceberg. Many of the things happens at the background which takes most of your effort, energy, and time. So let's say the solution to your problem is machine learning, then you need to start with a data preparation for that specific machine learning task. Whether you are creating a classification model, or you are forecasting some values in a time series uh, fashion, or you are going for some advanced things which are related to computer vision or NLP. Whether you are trying to classify images, or whether you are trying to predict the sentiment from some textual data, based on the specific task you are doing and process you're going to follow, you need to sort of tune your steps according to it. So now, let's say you are building a machine learning model for the tabular classification. You need to start preparing the data for it. First, you need to gather, collect, go and search that which data table lies in which database, what all data tables are important, and how I can fetch it. And also you need to take care about the security of data, that many of this information is very can be very critical to your organization, and you need to make sure that you are having clear policies in order to save that. um, you need Once you have collected the data, you need to first validate whether the data is correct, whether it's not garbage, whether it is updated, and then you need to work on cleaning the data, which mostly takes most of your time in a data science project. You might not initially get an understanding of what is written in the data and what indicates what. You might need to collaborate with different teams who were responsible to feed in that data or generate that data, to understand that what led to which data table, and how you can use it. So once you have prepared your data, cleaned it, you need to think about what models you can apply. Now there are tons of models available, and you can start thinking about directly that, okay, which is the best model, which is the most advanced model, but that might not always be the way. You need to understand the distribution of data, the sparsity of your data, and also what is the balance or imbalance in your final target data is. Based on that, you should research that, in that specific case, which models have worked best. You can read research papers, you can go through some of the past projects, similar projects which are done by different people at different organization, and understand that, which model helped them, or which technique helped them, or which parameters help them to, get better results. So basically here you will be having different questions which you need to answer while going through this process. Like, what are features you want to use? Okay, there can be hundreds of features, but using all of them will not be wise. You need to understand the feature importance, what feature is impacting your output, how many number of features will not lead to high dimensionality to your data, and also how you can better encode your data. Not all of the feature will be in numerical format, they may be in categorical format, or they can be in some unstructured format. You need to figure out a way to convert them to a format by encoding, which can be used by your machine learning models. The second question you can ask for is like, which metrics you're optimizing for. Now, based on different problem you're solving, trying to solve at your organization, your business leaders might want to optimize for different types of metrics. You may only think in terms of accuracy, but you also need to think about recall, precision, and other matrices based on the case in hand. Which model to use? As we already discussed, you should research a bit about distribution of your features and the target variable. Now, once you have built a machine learning model and you have got a decent accuracy, or the metrics you're optimizing for, you need to think about how to test it. So I guess this becomes a very critical stage, because when we study about data science theory, it's just you pass your training data set and you pass your test data set and you get accuracy, and that's your final accuracy. But in practice, it's different. You need to think about the real-time scenario, that how your model will be in use. Okay, how the data will be coming, at what your model will get triggered, and at what point it will be giving output to which people, and how they will, by looking at the output, how those people will interact, and how that interaction will in loop change your data features, and again change your output, your prediction. So that's a whole cycle you need to think about, which we in general doesn't think about when we are just studying about data science. The next critical thing is, how do you explain it to your different stakeholders? Now, in your team, maybe everybody understand about all the data science terminology, and that's very handy to them. But when you speak about different product people, engineering people, business people, business leaders, they become very um, businessy about it. Basically, for them, what matters is that how you are either solving the problem or improving some result. Okay, for them, the data, the features, the hyperparameters, and all those terminologies might not make any sense. So you need to figure out a way that how you can communicate your process and your output to those stakeholders, and also help them understand that how they can use it to their benefit. So most of the data science projects stop here, but in my view and in my experience, we should also think about how you can reuse all of this work. Now, in one organization, in different departments, people will be solving very similar problem, and you can use one process created at one problem to many different problems. So whenever you are creating or working on a project, you should always think about, can I solve some other problem in the similar fashion which is exist in my organization? And this will help scale your projects to a different level. The next thing I would like to discuss about is the documentation and version control. I guess this is something we should start thinking from the moment we think about initializing a project. Having everything documented, well structured form will always help you explain and understand everything in future, and also to in every step. Because if you want to reuse it, you would want to know the previous documentation and different versions of your data, your model, your features, your encoding parameters, and everything. If you want to test, you need to know what were the tests which were executed before. If you want to explain, it is needed. If you want to understand which model to use best, you need to know which model have not worked better before. If you want to optimize for metrics, you need to know that how it is optimizing for, and what were the outputs created. And to understand what features to be used, you need to have a list of everything and the distribution of every feature and how it is impacting your final target variable. Basically, documentation of everything from start to end will make your life easier in longer run. Okay, once we have decided on model and we have everything in place, we want to deploy your model in production. But many people ignore here is the maintenance of that model. Usually people think that once you have applied your model, it will give you perfect prediction all the time, but that's not a case. With time, your data decays, your feature decays, and with the change of season, the patterns of the data from which the prediction should happen changes, and that's where the model gives either poor results or it doesn't give any result at all. And so you have made your model to learn the data in hand and those patterns in hand to give the prediction, but you have not made it learn how to work with the changing data and changing pattern over the time. Okay, so you need to keep on updating your model based on the change of patterns of data and the scenarios for which you are solving the problem. um, and sometimes you actually need a human who will be always keep on updating that. um, Once you have done and implemented your model, you have tested it, and also figured out a way to periodically do the maintenance of it. We need to keep on repeating it and also keep on checking the priority. Now once you put your model in practice and in use, the at some point priorities of the use of that model will change. Let's say you have built a model or a process to recommend uh, product type of product A, but by the time your model is live and in use for, let's say, 1 month or 2 months, you have actually developed a new product itself, which is product B. So now you need to think about how you will recommend for the product B. So now the priority of your previous implementation changed to a different product. So or you can get to a different, more critical problem to be solved, and you need to sort of keep this project on hold and move on to other. So those repetition, priority checks and iteration should keep on happening for a project until you know that it will be keep on up and running by itself. In the end, what I would like to say is, as data science has the word science in it, you will need to be experimenting, researching, and stay updated in order to bring the best out of it. Uh, the expectations are that it works always, that it works in time, but that's not the case in reality. Um, you need to think about it holistically and long term, how uh, using data science methodologies can actually help solve a problem, or you need to think about other ways to solve it. So not every problem require data science, but the problem which do require data science, if you follow a consistent holistic process, then your impact will be large. That is all which I wanted to share with you. I'll just put in and share this presentation and add the credits of all the images which I have used. Thanks for being a part of this talk. Take care.